Hello everyone, welcome to the stream. Today we will be working on a project where we design a new Pmod for FPGAs. So in the last week, essentially, Kate Temkin brought up a topic where she was asking what Pmods there are to connect USB to an FPGA dev board. So this is the icebreaker, as you might know. And it has 1, 2, and 3 Pmod connections. There are some community-made USB adapters to connect to the Pmod connections. So let me rewind a smidge here. So on the icebreaker, for example, we have the USB connection. It's actually an FTDI adapter, which is a USB to X or serial converter. So you are not directly connected with USB to the FPGA. And Kate is working on Luna, which is a USB core. And this core supports a lot of different things and has a lot of functionality. But it requires the access from the FPGA to the USB pins directly. And so, yeah, am I muted? It's like unmute. Did I unmute? I hope I'm unmuted. I just realized that it's. Yeah. Okay. Good. I saw this this unmute exclamation mark in there, and I thought. Oh, you were muted. Okay. All right. Okay. Anyway, so let's get back to the description of what we were working on. So essentially, Kate's project requires direct access to the USB pins from the FPGA, and her core is originally motivated by the ability to do low-cost USB analysis and bug hunting, debugging, as well as vulnerability search. So it's like InfoSec-related stuff too. And she works for Great Scott Gadgets, which is Michael Osman's company. And they, you might know them from the HackerF, which is a soft what is it called? Soft radio? No, it's the wrong term, damn it. But SDR, software-defined radio, thank you. Yeah, my brain is mush for some reason today. Anyway, so software-defined radio, and they are pretty famous for that. So they try to make access for different debug and technologies that give you access to the insides of your hardware. And Kate is just today? No, it's not just today. It's every day. I know, Sylvain, thanks. But yeah, so they were working on. They essentially took part of the HackerF, which is the CPU part, and spun it out to a prototyping platform called GreatFET. So let me just show you a little bit of the things to explain a little bit of the infrastructure here. Great Scott Gadgets, GreatFET. So that's a microcontroller board that they are making. And for that microcontroller board, Kate developed USB analysis software together with Kyriad or Michaela. And this software is then running with an interface board like this, which is rhododendron, which is a shield that goes onto the GreatFET. And so let's see, like here. So that's rhododendron. So this one has a USB PHY on here, so you can get a loop from your device, and you can monitor the traffic, use USB traffic, and visualize it with a very nice textual as well as graphical interfaces. So it is a direct competitor to things like Beagle, or OpenVisla. And the software does support OpenVisla and many other tools for USB analysis. So the next step from there was to move on to FPGAs. And this is where Luna comes in. So Kate designed let's see, Luna, does it? Yeah, so this is Luna, and there's a hardware, this is the hardware for that, and it has also an ECP5 on here, as well as PHYs on here. So let's see, can I see it in full size? Oh, this is a tiny picture. Anyways, but yeah, so this is essentially meant as a USB analysis tool with better capabilities, and Kate developed a core for the FPGA. And then she went on and started just out of the goodness of her heart porting the core to all the different FPGA boards that all of us in the community make. And so it does run, as far as I know, on the ULX. It runs on the Orange Crab, and she ported at least parts of that, I think the full speed stuff, to the Icebreaker. So you can talk USB and use it as a USB core, but also it can have functionalities that give you USB protocol analysis capability. So it is a little bit of a ball of functionality in here. So, oh, this is the software. USB is the USB analyzer kit that Michaela is working on, so Kyriad. And so, yeah, anyways, so the ask was, do we have a USB Pmod to connect to the Icebreaker so that Luna can be ported to the Icebreaker, officially be supported there? And I know Konrad Beckmann, I think that's his name, K. Beckmann, he made a USB Pmod. But there is not a Pmod, as far as I know, that you can just buy off the shelf. And there he is. So yeah, Konrad Beckmann, he made a USB-C Pmod and USB-A Pmod. So that said, we realized we want something that is not exactly what Konrad built, and Kate made this KateCAD drawing, which she calls a napkin drawing, or many other names, but that's the drawing what she thinks would be very useful. That gives us the ability to try out USB cores on the Icebreaker or any other board that has the Pmod interface connector and doesn't have a directly connected USB port. So this is meant to allow us to do USB core testing development as well as USB analysis capabilities. So that's why it has two USB connectors, a USB-A connector, a USB-B or C connector. This is something that will be interesting, what we will decide on going on, but I probably will go for the quick path here. Wait for it. And then have control over the pull-up resistors as well as the ID pins for the what is it called, USB host. There's this the term where the USB target can be also a host. So I'm now forgetting the term. ULPI? Yes. No, there's no ULPI on this Pmod. OTP on the go, USB on the go. That's the term. Yeah, thank you. So USB on the go capability on this one connector, so it can be host or client. and as well as you have the USB-A, which is always the host connector, or you can feed through data. This is why you have those jumpers. So basically you bypass this and you only monitor the traffic with the USB pins. And no, there is no ULPI on here, at least not for now. Let's start with a simple Pmod to do the very basic stuff. The ULPI stuff makes sense for high-speed interfaces related things. I'm not sure the ICE40 is even fast enough for that, but probably knowing Sylvain and his magic that he's able to squeeze out of the poor up 5K chip, it's probably possible. Yeah, anyway, so this is the thing we will be building today, and converting this drawing from Kate into some physical object and hopefully make it available to people. So yeah, so that's the story. Let's see where we end up, because we are already an hour in, because the community updates took me way longer than they should. Maybe we will just take longer today. I will have to just take breaks and finish it. So yeah, I did. So several people were telling me, Peter, you have to try out those new themes for KiCad and color themes for KiCad. And I was like, okay, I have to try it eventually, and I did. So that's why this looks very different than it used to. So that is a color theme. So what I did is I took an existing Pmod and deleted a bunch of stuff from it to have basically a template, and we will fill it in, this schematic, with the necessary additional stuff. So we should probably name the signals first. And I need the napkin drawing on the other monitor so I can look at it. Come on. The other thing we should also probably look at is Conrad's design. Oh, come on. This is taking up too much space. I need more monitors, essentially. So yeah, let's clone also Conrad's design, Conrad's stuff. So let's go here. Will that work? Yeah. All right, and let's do this. Okay, so let's open this up. And Pmods, and then we have USB-A, Pmod. Okay. So this one is pretty simple. It's a USB-A connector connected. Oh, so basically it's just the one half of the Pmod connector. So my naming is this is a Pmod of 1x size, like one of these. Then this is a double where you can connect a wider Pmod to. And if you have just one row of these, it's a half Pmod for me. But yeah. So yeah, anyways, this is the USB Pmod. So yeah, essentially you get, interesting. So he has a USB-A, And this is exactly the right size for having just this one connector. So this will be interesting because I think our Pmod will have to break some rules here if we want to have both connectors on here. Unless we put them up, we can't. We can't. This will be interesting. Because the Pmod, the single size Pmod is just wide enough for a USB-A connector. So yeah, like this. If we look at this, let's see. Let me show you. Oh, come on. Yeah. So that is one size Pmod. And if we look at the USB-A connector, it's just, it would fit only on the end. You have combined USB-A and USB-C stacked. That's a good idea. Okay, so well, then we have to find that, I guess. So then we can have, yeah, that would be a totally good solution. Or a vertical, yeah, vertical one, sideways, and then plus. Yeah. Yeah, we have to figure out. Yeah. Oh, thanks, Jordy. Let's see. Oh, wow. That's an interesting connector. Yeah, let's do that. That looks cool. Oh, it's also like a vertical one? So it plugs in into the PCB in the back here? That's neat. That is very neat. I like it, actually. This is cool. Yeah, let's go for that. Oh, out of stock, no. No. No, there's almost 2,000 in stock. Are you sure? Seem to be 2,000 in stock. Can ship immediately. Oh, the second is horizontal version. Yeah, but I don't hate the vertical version, actually. I think if you have this in the icebreaker, so if we look at this, so if we look, let's look at the desk. Oh, I should talk about this too, but anyways, yeah, so if we have this, it might not be a bad idea to be able to plug in the cables just vertically into the PCB. So I don't think it is a deal breaker. Yeah, how much are they? $2 for a double? That's fine. Yeah, for this makes this is very reasonable. Yeah, let's start with the one that is available. Let's see if there is. Let me click on the other link you sent me. The horizontal version. Yeah, if we can find the horizontal version down the road, that would be nice. My God, there's a lot of metal work on here. Somehow these things look always, with all the amount of metal shielding and stuff, they look pretty menacing. But yeah, I think we should start with this one. I think that's reasonable for now. Yeah, I like the vertical one. So let's see the drawing. What is the... Yeah, it's all through hole. That's fine. Oh, now that I know that pasting hole is actually a viable path for certain things, so I'm not as afraid of these through hole USB connectors as I was before. So yeah, that might actually be a reasonable thing. And this footprint has basically USB-C on one end. Wait, this is just a pure USB 2.0 USB-C connector too. That makes life... $8 amps rated. Oh my God, that's a lot. Oh yeah, USB-C 8 amps and a USB 2.0 5 amps max. Wow. Okay, well, I don't think we are doing that. Yeah, it's probably for chargers, yeah. Yeah, where you have USB-C and USB-A in there. That makes a lot of sense. But yeah, I think we will use that. That's our choice. We might need to make a footprint for it though. If it does, I doubt it exists. Pony Louver, welcome to the stream. Thank you for the follow. Platinenmacher, also welcome. Thank you for the follow. Fusion, thank you for the follow. Welcome to the stream. Yeah, I missed a few new followers. I'm sorry about that. So yeah. All right, so we need to probably make a symbol for this, as well as a footprint. So that is probably the first thing to do. Does it have a numbering scheme in here already? Yeah, there could be Ultra Librarian footprints on here. Online catalog, featured product. Yeah, I don't have Ultra Librarian set up, I think. But there might be a... Okay, yeah, it really depends on... yeah, let me check. So, anyway, so this is Conrad's design, and it has the protection diodes here, which is nice. We might add the protection diodes. Discard changes. Let's see. And then let's open the other one from him, just to have the reference. And that is a USB-C connector. So it is, he has two separate Pmods, one for USB-C, one for USB-A, and we will be making a combined one. Oh, and he has, all the diodes are separate here. Interesting. Pull up, pull down, oh, for like pull up, pull down arbitration stuff. Interesting. Low speed device, pull down for host mode. Wow, that's elaborate. Yeah, we might look into this at some point. Wow, it's, why is every, I was like, oh, in a simple project, let's make a USB. Jared, you're mean, but so Extracto is this coffee roastery in Portland, Oregon that Jared and I like to frequent. When I like going there when I'm in Portland. They have really good coffee. So sorry for the tangent, but this is important. And Jared is teasing me a bit with having a good coffee from Extracto, but as a rebuke, I have Extracto coffee here that I'm making every morning for myself. So so I am not completely out of my good Extracto coffee. All right, so if you just USB your USB-C to, it's really easy. Yeah, that is true. Well, I was thinking I will be sending you your Bitsy, Jordy. So yeah, if you want to pick it up yourself, that's fine. Hopefully, I will come around to assemble them finally. That is lingering, unfortunately, longer than I wanted to. Oh, you will be here on Sunday. Okay, welcome, welcome. I'm looking forward to seeing you at least distance wave. So yeah, anyways, that is pretty interesting. I don't think I want to go all the way down the rabbit hole today. I will try to avoid that for now. The CC pins, right. Source mode. Oh yeah, we will have to do something with those pull-ups. That will be fun. Okay. But the CC one, I wanted to just wire it up as a downstream device and be done with it for now. But first, oh, there's the naming of the pads. A4, A5, B5, and so on. So this is the connector pins. Let's see, where's the PDF? There's the PDF. Oh, these are not named here yet. I will have to do that. The problem is I have to have a symbol that I think contains all of this stuff, including the additional connector pins. But let's look in KiCad what we currently have in symbol-wise. So let's open the cancel file, open recent, and let's open this. And let's go into the schematic symbol stuff. Let's see what we have available. Yes. Conrad, welcome. Welcome to, nice to have you here. Yeah, and thank you for sharing those schematics. They are very useful. So I wanted to be, we have to strike a balance between being as flexible as possible and not. I don't know yet. I think we are out of pins at the moment, but we will see down the road. Let's make the simplest circuit first, see where it leads us, and then we can revisit it and make it more elaborate and more like functional and whatnot. So I already see this will not be a one stream done and ordered design somehow. It's pretty clear already as USB, as things tend to go. For funsies, yeah, you will be probably faster because you don't have to talk like I am. Yeah, all right, so let's see. Why is it not opening? Come on, library. What's happening here? Why are libraries not opening? That's so weird. Okay, connector, USB. Connectors, just connectors. Connector. USB, there are multiple. Yeah. On the go. B. 3B. Yeah, that's interesting. So yeah, I doubt they have this. And I don't even know how I would name this. A combo? USB AC combo, probably. USB 2.0. USB AC receptacle, USB 2.0. I think that is the naming we want here. So we want to probably take this one and expand it with the USB-A pins. Does that make sense? I think that's the way to go. All right. Do I have the PKL stuff in here? Yes. PKL is here, and we have connectors, so I can copy Oh, I should make sure that my library here is up to date. Pmod lib let's pull. Oh yeah. Why is this not up to date? That's weird. Oh, this is Pmod. It's because yeah, Jordi did a lot of new additions to the library, so that's why. PKL, CI, and call it updated PKL. So that's good. So now. Connectors. Yeah, I should know where C is. Connector. Like this, and then file save as in PKL connectors. There. And then we should rename this. Like this. USB AC combo receptacle. The datasheet is not correct. We should delete this. Yeah. Yeah, it did rename it here, I think. Yeah, good. Value. Yep. So it is updated. USB Universal Serial Bus Type C and Type A USB 2.0. USB 2.0 only USB Type C and Type A combo receptacle connector. Okay, so that's saved. Let's save this. Now we need to add the D- D+ for the other connector. The question is VD plus D-. So we probably should prefix it with like D plus D-. So CV bus CC, like prefix that all with C, I guess. Yeah, but maybe, yeah, I'm struggling here. Power input. Because there are two separate ones. There's the CV bus for the naming so that you know which one belongs to what. And on the other hand, you are right. This would be a different pin numbering. This would be just 1, 2, 3, 4. Make two symbols. Have like a sub symbol. Right. This is not a bad idea. Yes, this is not a bad idea. Make a number of units, make 2. All units are not interchangeable. Okay. And then if I go to unit B, oh, I don't remember how that worked. If I unit A is this, unit B, oh God, what's going on. Yeah, so I'm deleting it only from unit B. So we can actually do this, I guess. And then I can unit A. Ah, the case cannot be deleted, which is super weird. Yeah, I'm trying to figure out how that worked. If I delete it here, it is also deleted here. This is the annoying part. But I want them to be completely independent. And there should be his alternate symbol. Click this option if the symbol has an alternate symbol body style De Morgan. Is that the trick to do this? I don't know. Anyways, I need a short break again, unfortunately, but yeah, it would be good to figure out it's like how I can make the drawing of the body different on the two. Unless I make something that looks the same for both of them. This is weird that I can't, that when I delete this line here, oh, yeah. So that would enable this function. Keycard Y, yeah. There's some weird things sometimes where I'm like, why are you keeping the body the same? This should be an option. It's like you want the body to be the same for both symbols or not. But I'm pretty sure I was able to change that. This is the weird thing, because I am pretty sure this was possible to have them look different, because the bodies, like, for different components of different units are different size even between yeah. Oh, okay. Anyways, I'll be right back. I'll figure it out in a minute. Alrighty. There we go. All right, so figured it out? Tell me. Do you want to jump in voice? You can want to explain it? Discord is open. I'll just have to copy the primitive again. Oh, okay. All right, so basically I do this, right? Copy block, essentially. Then if I delete this, come on, why is it not deleting things? What the hell? Why is this delete not working suddenly? Ah, God. Okay, anyways, and now if I paste it, yeah, so I paste this here, unit A, unit B. Okay, there we go. Come on. Yeah, now there should be. I probably did it in some weird clunky way, but yeah, anyways, let's see if that works. Ah, shit. I should have been more careful with the grid. Ah, so annoying. God. Grid. Yeah, now it's all off. That's a good question. Unit A. Does it have common to all units? Ah, there you go. Okay, yeah, Conrad, you are correct. That's the correct diagnosis here. Yep. So can I do something like that and mass edit this? Probably not. There were some options for some of this stuff. Common. Cancel. Oh, what? So I basically have to go through all this stuff. Oh, and depending on which one I choose, it goes from one to the other. Okay. I see. So if I go to A, I should be able to basically say this. That will be fun. Yeah, so basically I think what... Yeah, maybe start over. So essentially what happened is when you copy and paste, I think it changes that flag. But yeah, it's like, why is KiCad being weird with selecting things on my machine? It's like, obviously this is still a thing. I'm hovering over an object and I want to edit. It's like, why is it not detecting that I want to edit this? So weird. And I can't edit this globally. So what I could do is remove that flag in the file, which would be probably faster than having to do it one by hand. Because why have a list of all objects of the symbol that you can edit in a bulk manner? That would be a nice addition, KiCad. Just give me a drop-down of all the objects, just like every other Inkscape and Friends has, where I can just say, it's like, please edit all the common variables of all these objects in one go. You know, that would be great. I shouldn't be getting so angry about this, because it's like, then implement it, Peter, just do it yourself. It's like, yeah, I know, it's open source. But these are really simple things in theory that would make life so much easier. But yeah, let's see. If I save it, how does this common to all objects look like in the library? Oh, it's a file, right, because it's symbols. AC combo, and oh god, yeah, right. Oh, this old format sucks. I hate that old format. I think this is like one of those weird numbers, like letters at the end. Yeah, it's like the way selection works currently in PCB new, as well as in the schematic stuff, is weird, to say the least. Like, I am getting on this particular computer different issues. It seems to be something OS and like window manager related stuff, because I reported the issues I had in PCB new with selection, and the KiCad devs were like, we cannot reproduce it. And so it's like, it has to be something that occurs sometimes in specific situations, depending on some weird external factor, which I assume is like a window manager issue. So okay, so we have those lines. I want to figure out, I would have to look into the format. These are pins, P is pins. X are labels. Yes. Okay. And there was some option. Oh, right. So you have, oh god, yeah. There's something related to how many times the numbers of the coordinates are being listed, if it is in one or the other, I think. And I don't remember. So let's see. There is the specific, it's like, yeah, let's see, I shaved this. Wow. KiCad symbol file format. I did find a good library 5 formats. Right. So F is something we don't care about. This is the fields. FN, user fields, footprint, filter section, alias, FN, user fields with FN. Okay, I got that. And then the draw section, drawing section, there we go. Radius, start, end, part, start x, y, x, and start, circle, rectangle. F is for filled, N is for not filled shape. De Morgan alternate shape. The part parameter indicates which of the parts the shape applies to. Oh, P is for part. Radius part. 0. Oh my god. Okay, A. Start end. Radius start end part. So these are the circles. Filled, not filled. Okay, I got that. So I should probably diff it somehow. Okay. You probably are screaming in the chat already. On the other stuff and the symbol push to make it up. Okay, fine. Yeah, so Jordi is working on the symbol. That's fine. Okay, so let's get to the other stuff then, because this is becoming boring. Cancel, let's do unit B. Oh yeah, interesting. Oh, that was actually, I'm actually already almost like done with a lot of the stuff here. So I can just compare it here, essentially. So the triangle here. The circle here still has some disable the checkbox. Well, if I disable the checkbox in B, then it stays in B, but yeah. Hey Timon, it is. Where do I have this? It is this. That's a combo connector. AC combo connector. It has a USB-A and a USB-C plug in it. So essentially the order things, so Conrad, the order of things I do is important here. So if I do it in one, then it won't work in the other. It's like, I don't understand why this is being an arse. There we go. Okay, the square. Okay, we're almost done here. And this one. Yep. Then we have the arcs. Let's see. And yeah, there we go. And then we have the arc here, out, and then arc. And I think we're good. Yep, and then I just need to do the same thing for the squares here. And then we should be fine. Yeah, rectangle, there, rectangle, there, rectangle, and then I can copy in the symbol from the USB, just normal USB A symbol into the other part, I think. Okay, save this. There we go. Okay. Yeah, command to so I essentially can now delete these. And then if I go on A, yep, they still should be here, and B, they're gone. So I can save this. Now I can open the connector. Connector, up. And get a USB A like this. Shield ground. I don't think they need to be twice there. Copy block, and let's see if I can just copy it in here. Combo, unit B, paste. There we go. All right, so power, ground. We don't need shield twice, I don't think. So I can delete this, I think, to have that twice. And we should say here, USB A probably in text, but that's fine. Okay, so let's go in here and let's add the symbol and PKL connector, USB AC combo, connector. And there we go. So now we have the two. And then we can move this. So what was the order that Kate gave us? So just for reference, so this is Kate. So we have on the left side, we have the USB A. And on the right side, we have USB C. D plus, D minus. All right. So let's just copy that. Fim, welcome to the stream. Thank you for the follow. Move, and then Y for flipping. So we have this. Very nice. And then we can move this and have it on this side. And now let's keep going. We need to name this. Let's add some labels, net labels here. So this should be DPPU. So let's see. Let's be C DP. That would be one. Then USB C DM. Then we have, oh, they're actually lower here, according to Kate. So let's do that. Then we have there are multiple names we could use. Oh, selection in E schema depends on the grid size. You can't select stuff that is not on the grid point. Arcs are tricky especially. Oh, okay. Thanks, Silva. That's an interesting thing. Okay. Okay, now it makes sense why it was being so difficult. especially because you don't have like the handles, they are not visible. So the handles that you're trying to hit to like select something are not visible, so you can like try to target them. So yeah, that's probably the reason why it is being even more tricky. That was from Surfer on Discord. Yeah, thank you for that information. That's useful. Okay, so USB-C. Should we call it detect or pull up or PU? Let's call it USB CPU for now. And then USB-C. Does it have ID? Oh, USB, that's the CC 1 and 2, correct? CC. I think that's what we can do here. We can have what Conrad did with this, with the pull-ups and pull-downs on the CC pins to be either upstream or a downstream device. So yeah, I think that's what we want here. Okay, so on this side, we will have USB-A, DP-PU, right? Or is it high-speed pull-up or detect or something? Yeah. Like this. USB-A, DM, PU. And then USB-A, DP. And USB-A, DM. Like this. Okay, so that looks fine. Not sure we need the 3.3 volt stuff, but I'm leaving it here for now. Then we want the V-bus to be connected together, I guess. Or have the jumper to be able to connect it. Also, I don't have the 2-pin connector here, which I forgot. This should be the 5 volt V-bus stuff. This requires a bunch of like decisions. It's how do we jumper that stuff? Do we want to have it full jumpered so that we can supply power to the USB-A side or the USB-C side and be able to select it or not? So yeah, for now, let's just copy. Oops. Let's just copy this. Copy this. The shield probably needs. We will connect it for ground for now. It's just to keep it simple. And then so so let's make V-bus. Let's just name it for now. USB-C V-bus, and then USB-A V-bus. Okay, and then we need the pull-ups here, so that will be interesting. I don't want this here because it's in my way. Let's do this. Okay, so we need this should work. DP, DM. And then we need resistors. SBUs. Are they NCs? I think they are NCs usually. Serial bus? Yeah. Let's make them NCs. Yep. Thanks for confirming. Then we have the D minus. I wish I could rotate them. It's not a big problem though. Yeah, let's do just this. D plus. Let's do like this. It's a little bit squirrely, but I could theoretically swap them, but it's more intuitive if they are in the same order, essentially on the top and the bottom side of the Pmod. USB-C PU. Do we also have the pull-ups on the data lines? I think we do. So let's add the resistors. The next thing will be to add the footprint to make this just the basic design. I will probably add the diodes and the more elaborate circuit that Konrad came up with, but I don't think I want to do that on stream today. It's already 3, so we are very, very much close to the theoretical ending, but I want to have something put together here. So I know that we want the 5.1K resistors here for sure. So yeah, let's go and add the PKL resistors, device, PKL R. Is that, oh, that they are minis. Wait. I don't want this. PKL device, PKL R small, there, that's correct. And we want, for here, we want 5K1. We want 2 of them. Okay. Let's see. How do we do this? 1, 2, 3. Yeah. So let's make more space here. There we go. Oh, this is wrong. It's over there. Ah, Peter. So, like this. Yeah, I should probably do this. Yeah, I will have to change the size of the text here. Don't worry about it. There we go. Like this. So for now, let's have it this way. Like that. So that would be the CC. So we can decide if we want them pulled up. Yeah, just take it with a grain of salt. This needs more work. Let's leave even a note. Import more there we go. like this. So that's that, and then the pull up here, that should be, so probably I will move all this down to make more space. It's a multi-purpose Pmod. It is a host, a client, and a feed through for being able to do Luna related stuff and USB monitoring stuff. So it is like a multi-purpose and a dessert topping. Yes, it's like and a cherry on top and some and sprinkles. So yeah, it's everything USB related that you would want to connect to an FPGA. At least that's the plan. Well, not everything. That's, but you know what I mean. It's like trying to make it as useful as possible. Yeah, so there's even more going on here. So this is more of a placeholder in a sense, because Conrad made a much more elaborate system here. Let me see if I can just show you that on the... so I think that's here. If we look here in his USB-C Pmod, there is a PDF here. That should make it easier. Then I don't have to open it in KiCad. Let's see the raw thing. So yeah, he has a much more... It's not that complicated at the end, but it's more elaborate, because he has pull-up, pull-downs, full-speed device, and not, as well as the CC. He can select when source mode, pull-up, termination parameters resistors, pull-up to 3.3 volt, and default USB power. When sync mode, pull down both CC pins through separate 5.1 K resistors. So yeah, this is what we will be putting in there. I'm just seeing it more like a placeholder for now. Okay, I hope that makes sense. Oh, you finished the footprint. Perfect. So will that work with that weird symbol that I made? So they are basically steering diodes. So if you connect this CC to ground, it will create pull downs for the 5.1K resistors. But when it is high, it will not do anything with the 5.1K resistor, but be a pull up on the 36K. So you can decide what value of a resistor you have on pull up and pull down separately. So that's the magic here. Smart, yes, very smart. Smart with schmear. So yeah. Okay, we will see in a minute. Okay, so then we still need the... Yeah, I hear you. Well, Conrad, you made this board, didn't you? You made that Pmod, or didn't you test it yet? Is it working for what you made it for? So it's like at least one data point then. Okay, perfect. So that's, as we know, the policy here is works for me, so ship it. So we're good. Works for you, so ship it too. It's fine. Yeah. Oh, that's great. Okay, so I wanted to move the stuff a little bit here. I don't want to create an issue for myself, but like this. Do I need to go one more? I think I should. Let's do this way. Let's delete these. Oh, come on. Wire. So that I can make the pull up here. Yeah, I should make it as a separate thing anyways. Just like Conrad did. But yeah. 12K. Pull down for host mode. Pull up for low speed device. And then pull up for full speed device. Right. So pull up for full speed device 1. Is that not 1.5K? I thought it was 1.5K or something. Oh, with the diode, okay. Interesting. Yeah, so this also serves as a... Yeah. Same with 12K, which should be 15K. Okay. So you did measure that. So the 5.1K stuff should probably get the same treatment as these values here? Ah, okay. I see. Copy pasta. Delicious copy pasta. Okay, so I think what I should actually do is, instead of squeezing the resistors in here, I should make them as a separate section, just like you do. So yeah. And I should add those diodes. Should just copy this stuff from you and be done with it. I'm just too lazy at the moment. It's like I'm so lazy that I'm making more work for myself. But yeah, anyways, so let's... we definitely need the pull-ups. They're pretty huge. Yeah, I will probably use the diodes that I use in my designs, which are essentially in 0603 footprint, or the equivalent in diode packages. But yeah, USB DM PU. So this is the same thing, same deal. Same procedure as every year, James. Yeah, I know. Feuerzangenbowle also. Anyways, so I'm now completely saying weird stuff that doesn't make any sense for a lot of you. Anyways, so Christmas movies from Germany. All right, so I'm trying to figure out if I should do the same thing with the diodes on the other side or not. I probably should do the same system as here. So I should use the diodes that I have on the icebreaker. So let's do that this way. We have the rest, and we need all those jumpers, right? Yeah. Okay, so let's do it right. PKL device, PKL diode small. Well, let's do this, and then oh god, what was the number that I had there? Should probably open it up in what do I use here? Icebreaker hardware. I don't think I deleted this yet here. Hardware Icebreaker version 1.0e. And then PCB new Icebreaker. No, it's e-schema. Man, those names are weird. Fun fact, there was a discussion on the KiCad mailing list a long time ago if the names of the binaries should be renamed into something a little bit more intuitive and not fully historical. So yeah. Yeah. What? You can't open it? Error, loading schematic file. Does not appear to be a schema file. Oh, pfft. Yeah, of course it's not. There you go. Okay, that was dumb. Okay. What do we have here? There we go. So this is 800 millivolt F. That's what I named it. That's interesting. 800 millivolt forward voltage. That's what it is. And it's a diode Schottky SOD 523. So yeah. The question is, can I do this? Copy block. I don't think I can. It actually, they support. Yeah, they don't support it yet. Yeah, they don't support cut and paste between schematics yet. I think it's in nightly build. There's more functionality like that. Copy block, duplicate block, drag delete block. I don't think I can. Yeah, it does it in the it's not a global paste that I can do. Yeah, I know. That's the problem. It's like it only copies within the same instance of e-schema, not between two instances. That's the problem here. And I want to have open both of them and not close the other one. It's crap. Yeah, end of story. Yeah, in brackets, crap. There was no cut and paste whatsoever very recently, so it is an improvement. So yeah, in a sense, it's moving in the right direction, as I keep repeating. And then key, that's all I need to copy anyways. Key, and then the footprint. What? What did you do here? Yeah, I hear you. That's a weird thing. The enter was here. Okay, and then footprint. Footprint is here. There we go. Oh, don't show me this. There we go. There we go. Okay, cool. Now we have that. And I can start copying this stuff around. So we want D plus. Can I copy this text at least? I could theoretically just copy this complete section and then replace only the footprints on here. Yeah. Okay. File. And I can't append schematic sheet content. Could just do that. Yeah, maybe let's do this. Let's do this. Do you want to relative path to what? Oh, and then it overlays everything. Ah, huge. Oh, and it... Oh, God. Oh, God. And I cannot undo this? Are you kidding me? Come on, guys. Seriously? That is not okay. Okay, what the hell? Oh, man. That is not all right. Come on. Clip that. Damn it. Ah. Close without saving, but did I save enough? Anyways. Gonzik, welcome to the stream. Thank you for the follow. Sorry, you just joined in the frustrating moment here. Let me close this. How much will I lose? When did I save it last time? That is the question. Yeah. Is there autosave backups? Yeah, there was something. Let me just check. It's fine. I didn't do much. And I'm pretty good at saving stuff. Can I... Oh, yeah, I know what you're saying. I get it. I get it. I know what you're saying. Okay, let's do this. Project, icebreaker. Icebreaker, Pmod, USB. And then just copy that, cp-a, USB. Back, copy this, now close this. Oh, now save this. There we go. Now I can save this. And I can open the other one and see. Guys, seriously, this should be completely freaking unacceptable to do such things. It's like any action has to be undoable, or you have to have a massive freaking huge warning that it is you cannot undo this. In the worst case scenario. Yeah, see how much I would have lost? Can't undo anything? Yeah, IDA Pro. Yeah, I know. Yeah, I guess IDA is a very specific creature. Yeah, I have not used very much IDA, so I can't speak to that. So yeah, I would have to redo everything. So I think the cheaper thing for me time-wise is to actually undo it manually and untangle this stuff by hand. So yeah, let's do this. Okay. Like this kind of stuff. And guys, seriously, this is frustrating on a level that is pretty annoying. Vibas T. Yeah, I think this was just overlapping here. That's fine. And it did disambiguation junction. This, and this. Okay, so that should do it. That wasn't too bad. Yeah, Timon, we had this lengthy conversation regarding like UI stuff in KiCad. It's like, and I think this is really a worthwhile endeavor to try to help KiCad with the usability stuff. I really would like to see more happening in that direction. Problem is, it's a big project, and you need people that really know what they are doing. So yeah, I know, I hear you. So I think I can now delete this, and we should be able. So there are more connectors here. Okay, so that looks good. So essentially the lesson is, if I want to append stuff, like note to self, if you append schematics, move your schematic out of the way into some like far corner and then import the stuff, then that should be better. There are things hiding below the symbol. Okay, thanks. So I will, there we go. Stuff. Come on, stuff. USB pull plus. I don't think we need this. Where was that? Yeah. Okay. So that should be better. Okay. So now these can stay as they are. I don't think we need to rename them. We can just call them CC1 and CC2, USB pull, and this should be USB-C, pull CC1 and pull CC2, and you have them separate. I don't think I can do that. I have to pull them on one pin. I have to do it on this one USB-C CC pin. So I should call this USB-CC. Do they have to be pulled in a different direction based on them? This is the question I would have. Yeah. USB-C, CC. So this is one. Then we need also, yeah, Okay, so this is the interesting thing, because I think we will make 2 copies of this, and there will be a copy for that for just this section for the USB-A connector. So this part. And we want to replace the diodes with these. Right, so yeah, we are getting there, At least we will have the schematic ready today, I think. So let's just focus on that. Let's make that the goal for today. And then and this should be, oh, I undid it. Okay, that's 800 MVF, and then footprint. We had a footprint here, but it's fine. For now, let's just make the naming correct. And then copy and backspace. So move. So something like that, and we do that for all of them. Yeah, so pulling down to 5.1K is definite. This is the normal mode that I am familiar with, so that should be fine. Pulling them both up, that's what yeah, you are right. I don't know if up is correct. This is something we will have to look into. There is something with the polarity of the cable situation, and I don't know how that detection thing works. But does it matter in our case? Do we need to know which orientation it is plugged into? Even if we are the source? I don't think we do, because we are connected to both pins anyways. And they should be connected correctly. Yeah. The other day, Kate posted that she had a nightmare dreaming of she was at some event and had to, like, this was a dream. It's like she was at some event and had to correct someone who was just slightly wrong about the USB-C standard or something. And the reason was she was reading the USB 4.0 specification before going to bed. It's like, that's some other level. But yeah, I have read plenty of data sheets before going to bed. It's good bed lecture. But I'm not sure the horrors of the USB-C standard are the best thing to read before bed. Unless you're like horror. Oh gosh. Okay. So, yeah, paste block this. Ivan Doken, thank you for the follow. Welcome to the stream. Just on Sunday. Yeah, it's so far we had like a lot of ambiguity and problems and complexity with the data protocols and the connectors. Now we added also power to it. Woohoo! It's like, oh, how can we add more ambiguity, complexity, and confusion to a standard? Let's add another factor that is a knob that everyone interprets in a different way. So, woohoo! Yeah. Okay, sorry. Good, okay, that's there. Let's do this. And this. Duplicate block. There. Let's attach this. Yeah, I will worry about the... So let's move this guy down here. Okay. Oh yeah, the SBU stuff is on a connector. That's nice. Yeah, let's leave that so that we can make the SBUs actually available, just in case. Who knows what that will be useful for. Like 6 standards now, how to get power from USB. Yeah, official ones, that is. Yeah, great. Oh, isn't available? Okay, well, then problem solves itself. Thanks, Jordy. Yeah. Okay, so now I should do this and USB-C, USB-C, PU, PD. It should be popped, right? Because it's pull up, pull down. It's not just pull up. Yeah, I don't know. That's a very good question. And we should name this correctly. USB-C PDP and USB-C PDM. And then CC1, CC2, this is correct. Now we can take this and duplicate block. Like this. And this is USB-A PUPD. USB-P. Yeah, this one is separate. So this is USB-A. Oh, right. Now it's like I think this is the problem here. We cannot pull up, pull down the same thing. So we can only do the full speed device pull up and low speed device pull up. Oh man, that's a bummer. So we have to choose what we are here. So I think this section has to go in our case. I don't think we can have that. So we cannot do USB-C low speed device stuff. We have to use the USB-A connector for that. So yeah, I could do this. Oh no, I can't. I can't have a cross through this. Okay, whatever. But yeah, I think we have to delete this. I will leave this here for now, but I think we can't do that because we will need two separate control lines for this. Unless we add a jumper here that we can at least select which one is which. For host mode. Yeah, I can do that, I think. So 12K pull down on the DM and then pull up. So we should just split this. So okay, let me propose the following. Move like this, move like this, move like this, delete there, do this, and then do this. How about that? Oh, you need to do it on both? Oh, you pull down on both. Ah, I see. Can we use two resistors here then? Huh, maybe we can just do this then. 1, 2, 1, 2. And then, should it be two separate resistors? I assume. I don't want to make the same mistake as Raspberry Pi, obviously. Something like that. How about this? Two diodes? Oh yeah, because of the... Okay. Yeah, let's do that. Okay, fine. That's still all doable. Oh, come on, guys. Come on, wire. Stupid wire. There we go. Let's do this. How about that? Happy? Yeah, on D plus and D minus 12K pull down for host mode. So it's basically 15K because of the diodes drop. So yeah, this would be 1 point, yeah, whatever. Yeah, please, like everyone pitch in here. Yeah, I know only as much. Yeah, so we can do this. That should make it clear what belongs to what. So there's a design rule, like a in KiCad, that you use this grid of so you use in schematics, you use this 50 mil grid, but you place all the nodes on the 100 mil grid. That seems to be like a convention in KiCad for schematics. It is somewhere in the KiCad library standard definition or whatever. So that was something I read very early on. USB-C pubbed. USB-C PUPD pull up, pull down. Oh, I didn't rename this? No, I did rename USB-C PUPD. Did I misspell something in here? I'm not sure. USB-C PUPD. Oh, in brackets you want like... Yeah. Okay, thanks, Timon. Thanks for confirming. Oh, okay, yes. Wonderful dyslexia. I love it. It's like the letter flippers, I just don't see them. It's just, they are completely non-existent for me. So yeah, please take a corrective on my dyslexia here. Thanks. But yeah, oh, I made the same mistake here now that I pay attention to this. Okay, good. Yeah, I will have to replace the resistors at some point, but will not bore you with that. And we should like this, and then like this. Okay, so this is the section for the pull-up, pull-downs here, and we need also to name this. And then this. Okay. Okay, what else? Are we missing anything? There's an app note. Thank you, Jordy. Have a great rest of your day. Yeah, I will be wrapping it up probably in a minute anyways, because I think we have the schematic pretty much nailed down. I will probably just finalize a few things here and share that for commentary. So I probably want to clean it up, making nice sections and documentation, and share the schematic at least, because I guess there will be more inputs on this, what we should do. So do something like that, put it nice in the center, create nice blocks with documentation, what is what. Okay, we can delete that, I think, now, because we imported that. Oh, and I need to add the 5-volt stuff and the jumpers, right? So this is something we should still look into before we go. New York 167, thank you for the follow. Welcome to the stream. Yeah, it's also to a certain degree for me also like somewhat of a joke about complaining about USB and its standard. It's like there are definitely worse standards than USB. USB is confusing and annoying in its own right, but there's plenty of other standards that are much worse. I'm sure it's not like this is the only thing that is worth complaining about. Yeah, revision 2. Oh, this is like the complete PDF here. Oh wow, a zip file. Yeah. The app note that you're referring to. So let's see. Introduction to USB Type-C, and there's an app note that is, oh yeah, with all the pins. That's nice. Yeah, I think we should create a USB specific forum section to discuss these things. I think what I will do after the stream, I will polish up that schematic and post it in the forum for discussion, so that we can talk about this. So look out for that. If you don't have an account in the forum and you want to be notified, make one. Yeah, I'm not opposed to reading the actual spec per se. I'm sure it is. There's a lot of interesting stuff in it. Yeah, so we need the jumpers because we want to make those connections here. So I should probably at least add pin headers like this to add the data line jumpers. We can think about, so an alternative would be doing something like we have on the TieGuard, where we have multiple switches to do the jumping. Oh God! Wow, that's very elaborate. Let's say this way, right? That's not a bad thing, to be specific. But yeah. Okay, so we need connectors. Connector generic, and we need just a 2-pin connector. Yeah. Do we have jumpers? Jumper like this. Jumper dual. Do I want jumpers or do I want pin headers? Yes, so that is the idea behind the schematic that Kate made. Let's see. Let me show you really quick for reference again. There we go. So that's Kate's contribution here. So we have the 5-volt from the icebreaker, which is the auxiliary connector on the side. You see this? Let me see. So if you look here, there's this connector in the between the Pmods as well as to the side here. And this is the USB 5 volts from the host here. So you can inject 5 volts. And that's so this pin header I will be adding for sure. Omaro Mendoza, welcome. Welcome to the stream. Thank you for the follow. Yeah, so I will definitely add, so we will add these jumpers, but we also have to think about how we want this. I think we want a jumper here, and the connector here, so that we can do all the combinations of stuff, where we can feed through this, but we can also inject power to one or the other, depending on how we want things to be. Correct? Or is it irrelevant and the USB-A always should get the V-bus connected? I think it doesn't make much sense to not have it connected to here. Unless, yeah. Yeah, anyways, I will add this 2-pin connector here. So let's do that. Connector. No, these are the I want the connector generic mounting pin. Will that be good enough? Yeah, let's do this. I think I had a different connector on the other Pmods. That's what I remember. Oh, I think it was a 2-row. Right. I think I know what it was. Okay, let me do this instead. Connector generic, and this was a 2-1. There we go. That makes much more sense. So that would be the 5-volt. And it is, ground is correct. 5-volt, and then the V buses, VBA, V bus, can connect that. All right. 3.3 volts. Right, and then we need the jumpers to connect DP and DM. All right, I'll be right back. There's multiple jumpers. I didn't add the jumpers yet. So there will be a bunch of different stuff. Just wait for it. Anyways, I'll be right back. Sorry again. All right, sorry about that. So yeah, why is this feels weird? What's going on in here? All right, so we need the 5 volts here. Power 5 volts, just to indicate it correctly. 5 volts. There we go. And then we have. Let's add the jumpers. So for example, this one would be, so this would be an option of doing it essentially this way, where we have jumpers for everything. So move this one like this. have this, and then do this. Up. What? You. There. There we go. Like this, and then have the 5 volt again here. Because you don't have to connect the icebreaker to this, so we can have essentially the V-bus connected through the 5 volts here. So we have those jumpers, and now we also have, we should have jumpers here. Let's do this center, and this is for monitoring and having essentially making an icebreaker into a USB analyzer. One, 2, 3, 4. There we go. And then copy, 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 copy. There we go. So now we have all the jumpers. So yeah, that's the idea behind this. Does that make sense? Anything else we need to add to the schematic before we go? Let's see. So we have the much more elaborate pull-up, pull-down system from Conrad. We have the USB connector with like USB-C on this side and USB-A on this side. We have jumpers to connect the data lines together so that we can monitor them, just sniff them essentially. We have a way of controlling a source and a sink for USB-C, as well as this. The only thing that I think is less functional is probably the fact that we cannot do a low-speed device on the USB-C side. We can only do it on the USB-A side. But I think that should be good enough. That should be fine. I think that's a reasonable trade-off with the pins that we have available. Yes, yes, I think that part is fine. So that's an improvement on top of what Kate's schematic did. Yeah, so now the thing that I will have to fix is all these resistors. I should replace them with the with my symbol. And I think I might start with the PCB layout, poke around with it, but probably we will do the layout of this next week on stream. That makes more sense. Again, I don't think I will be streaming on Thursday because there's so much to do, but who knows, maybe I feel very motivated and I really want to work on this, and I might make a stream earlier, but I don't promise anything. I don't think this is... Yeah, there is the stray resistors, that is correct. That is almost on purpose. That is because I want to replace these here. Like this. I need to adjust the size of the text though. I don't think this is correct here. Yeah. So I use the smaller symbols here. Not sure it is really necessary. We can also swap them over for yours, the ones you used. So that's fine from the standard library. So that's why there's the stray resistor here, because this is symbol from my library instead of the KiCad library. That's all. Okay, so I think. What are you thinking about? I am thinking in the ocean that yeah, so yeah, I definitely need to create the blocks. something like that. And then we can add text here and say text size is 1 at least, if not 2. Pull up, pull down network. Oh, that's bigger than I expected. It's probably 1 then. Yep. Like this. And same thing for this side here. Okay. And we call it USB-C. Let's do it this way. Okay, and oh, thanks, Conrad. Yeah, I try to make things clear. I don't. It really depends on the board how much effort I put into organizing stuff. Sometimes I feel motivated, sometimes I don't. But yeah, this shouldn't be a separate thing. It should go here probably. Oh, we don't have the SBUs anyway, so we can delete this because we don't have that on the connector. But we definitely should have additional pins for accessing the CC1 and CC2 because that might be useful. And it's not VBus, it's USB-C VBus, I think. Let's do this. There we go. I caught something. There we go. And then we can add a nice square here. Yeah, this is the general stuff, so I think we should leave it as is. Okie dokes. So these jumpers, we should also name that. DP, is that DP? Yeah, USB DP and then USB DM, right? USB DM. And then we have USB AV bus, USB AV bus. Nick Horman, welcome. Thank you for the follow. Suppose that, did I read it right? Yeah, thank you for the follow. Welcome to the stream. Yeah, yeah. There's a lot of stuff that would be nice to just steal from other tools. Yeah, I can't. I'm looking forward to some more stuff being. Oh yeah, I should just call that USB-C. This should be clear actually, shouldn't it? Pmod connector, USB-C connector. I think it might. Oh no, actually it doesn't say. It says only here in the text because it's just the USB AC combo receptacle. Yeah. Jumpers with JP, so you get JP USB V bus. Yeah, that's probably a good idea. JP USB DP. Yeah, JP, and same thing, JP USB DM. And this is aux 5 volts, 5 volt. And this one is JP USB A V bus, and this one is JP USB C V bus. Yes, and this one is CC or CCC, something like that. Okay, so these are just the values to make more description. I'm not sure about the USB-C connector and Pmod connector stuff. This is more cosmetic stuff now. This is nice. We have those nice blocks. That's good. That's a good start. Like this. Then I can squish and constrain this stuff a little bit. This fella here should live in the corner. Yeah, should live in the corner here. Maybe we should. Yeah, and now I'm only like yak shaving and like looking at this. So yeah, I think that would be it. I think we have everything so far. The only one more thing we can add are the protection diode chips. So that's another thing we could add to the schematic. Let's see. Where's Conrad's stuff here? Nope. Let's open the raw in a new file, and then let's go back here, and when we go to USB A, the PDF here is here. Oh wow. So this one is in a different color scheme, but these here could be useful. What happened? By accident I pressed stop here. So yeah, let's see. So you have D minus and D plus. I was feeding them through on my designs, feeding it in one side and feeding it out the other. Why do you have them connected together here? Is there like some specific reason? You have also the Zener diodes to protect from, yeah, this is when the other side has like 5 volt pull-ups. You can get USB LC6 with 4 I/O rather than 2. Perhaps use them for the CC pins too. The USB LC6 2 is only 2-pin protection, and the USB 6 is 4, has 4. I see. Oh, yeah, so you mean the package for the diodes has a bigger, has more pins, and I could use just one package. The problem is I already have these for different projects, so this I would rather reuse a part that I already use instead of adding an additional part that I have to source if I can avoid it. I think in this case I would rather do that. Yeah, it would make more sense. Yeah, I agree. This is a great idea if it was a blank slate design. But I think in my case here, I would rather just reuse a part. let's not do the same mistake I did before with the importing. So let's do the following. I will save this. And close KiCad completely. And then go to the terminal. And go to the USB thing. And then eschema USB.schematic. And now file, open recent. Let's see. Icebreaker bitc. I think we have the diode in here. Yes, we do. That's the one. And then paste. Huh. Okay. Should exist. Yeah, it exists. Oh, it's some weird thing where I have to like reload the thing. Ah, God. USB MISC, USB LC62. Yeah, there it is. Why? Okay, whatever. So ground and VBus. And I think yeah, that is probably fine. So what I did in my design, I actually had the internal, external, like I had separate nets where I have this fed through this part. It's totally fine what you're doing, I think. I just did it differently, that's all. So I think I will also do it differently here and just make the externals and only connect the internal signals through the jumpers. So leave them and then rename this and add these guys here. So yeah, let me show you what I mean. Okay, so I can delete this, and then copy. Copy. So what I do usually is do this. That's external. It's just a convention thing essentially at the end. Move. Right, now the question was, did I? Yeah, I think I went like this. I have to be careful with the VBus here so that it fits, because I'm running out of space now again. Yoo-hoo. So let's move this stuff. Let's make space. There we go. Okay. Ground, good. So now, like this, then we want 1, 2, 1, 2, 2, 1, 2, like this, and then we want like this, and then like this, something like that. And then we can go to ground here, and then 5 volt up here. And this is the V-bus, sorry. So V-bus, oh, I should have rotated this, right? So to connect V-bus here, whatever. Yeah, something like this. I didn't mean to make it so messy. I'm sorry. Yeah, it's so in this particular case, because we are using we have yeah, at the end it doesn't matter because V-bus is 5 volts, so we can get still 5 volts onto the I/O pins of the FPGA. What we need separately are actually Zener diodes to protect from having 5 volts on data lines to make it fully safe. So yeah, this is something that Konrad did here. He has the diodes here. Yeah, they are 3.6 volt Zeners. So we might do that. Yeah. Yeah. Thank you. That's a solution. So this. And then we went this. And that. And this. And that. Perfect. Yeah, and we should do the same thing on the other side for the USB-C connector. But this fits nicely. Tab. Let's make space. Let's do this and then copy that. And then Y. And yeah. Something like this. Very good. And then we can go like this. 1. Whoop. What happened here? 2. Like this. To jump. And then we can go to V-bus like that. And we can go to, and this is the fun thing because now we need D minus. And then we need D plus, like this. There we go. And now we need new naming. Like this. Maybe I should just put it here. And then DM, and then X, and XDP. There we go. Cool. The ground connection. Well, yeah, I think there we are. I think this is it. Anything else? I think yeah, I'm sure we will come up with some additional stuff, 100%. But I think this is it for today. For our endeavor in making the USB Pmod for multitude of applications with USB-C and USB-A. So yeah, that would be it for today. I will probably do a little bit more polish, commit this change. Calculate resistors. Good point. Let's add that here. And I think this is in here. I wish we could make this, yeah, to do. Something like that. Calculate resistors to compensate for diode drop. Yeah, that would be it. So that should be, maybe I will make it bigger, you know. Let's make it bigger. There we go. It's nice and fat. Let's deal with it at some point. 2 inches, yes. Bam! All across the text. Cifredo7, welcome to the stream. Thank you for the follow. Awesome. So yeah, a little bit more polish will happen, and for now that would be it. Thank you so much, everyone who came today to the stream. It was a lot of fun as always. Yeah, I hope I hope you had some fun too. Yeah, I really appreciate everyone being here. Please join again and come back. We will definitely continue work on this and many other projects, and hopefully learn and teach each other some things. I always love learning from this wonderful externalized brain of the internet and you all wonderful people. So yeah, it's a great thing, and I hope we can continue being nice to each other and and make this place a better place by making wonderful communities with good people in it. So that said, take a peek at our new forum that we created. So I will definitely be posting this schematic over there, and just to give an opportunity to discuss anything and share ideas if we need to improve something. As well as on Discord, which is being posted here on a regular basis. Join our Discord. And the important thing is the difference between Discord and discourse is Discord is the chat and discourse is the forum, which I showed you before. Yeah, and as always, big thanks to everyone who is subscribed here to this Twitch channel and is pitching in some money into running of this channel and the work that goes on here. I really appreciate that. I am as grateful for those that are just here and just hanging out and being part of this. I really appreciate that too, for sure. But yeah, the tip jar is definitely helpful, and it's not only motivating but also helps to pay for the for the gear and my time. And yeah, so check out the 1bit² store if you want some hardware. As I said in the prelude, the orange crabs will be soon available in the US store, which are the new ECP5 FPGA dev boards from Greg Daville, and soon after they will be available in the German 1bit² store, so check that out if you still need one. And as always, also big thanks to the Patreons who are pitching in greatly, and it really helps. Thank you so much for being so generous. And as always, I would like to give a shout out to everyone who is in the shout out tier and beyond. So big thanks goes to Jamin, Aki Van Ness, Ben Vanik, Brennan Ashton, Drew Fustini, Edward Borden, Go Jimmy Pie, Jeff Wang, Jordi Paki Rodriguez, Kelly, Mathis Schmieder, Matthias Pritchett, Miha Benovets, Sid Price, Tom Keddy, and Sean C. So thank you very much, all of you, and you can find the Patreon down there if if you want to check it out and help out. So I will see you probably next Tuesday. There is a slight chance, but a very small one, that I might stream earlier, but I doubt it. There's a lot going on, a lot to do. So probably next Tuesday is again a time to hang out, and we will either continue on this project or something else. Yeah, thank you very much. And yeah, as always, if you have been, thank you for watching. Bye.